In this question, they say that the measurements are all correct to nearest cm, which implies this is not exact value. It may be slightly shorter or maybe slightly longer. And then we are asking the actual area of this shape. And then we need to find the range of the value of x. So to calculate the area of this shape, first you need to find a method how you calculate it. It's obvious that it seems like I give you a rectangular paper and then you just cut out this part, right? So usually our calculation is we using this to subtract the small rectangle there. Why I say it's rectangle but not square is because no one guarantee is exactly 2. Maybe this is longer than 2 while this one is smaller than 2. And another key point is about the measurement. If there is a ruler and then our mark is 4 cm, the previous one is 3 cm and 5 cm here. Then that means the actual length can be slightly less than that. That means 3.5 cm, you will still consider it is 4 cm. Or it can be larger than 4. If it is less than 4.5, then you still consider it is 4 cm here. So this is the minimum case of this length, and this is the maximum case of this length. And then to calculate the minimum and maximum here, we need to consider 2 cases. First, this is the actual situation. How about if we consider the maximum possible area? If I want maximum area, then our original paper, of course, is as large as possible. It's better. This one is maximum. But if you're talking about the removed part, of course, we remove as less as possible, right? So this one, minimum case. Then we look at the original rectangle, 4. If we want to consider a maximum case, then of course our limit is 4.5. 4.5. It's kind exactly 4.5. It's just give you a limit, a boundary. You can just simply use 4.5. It's not good to use 4.4 because 4.4 we still have 4.49, we still have 4.499, something like that. So we just simply use 4.5, and that's why they do not provide equal sign here. They don't accept the equal case is because of this reason. So similar reason, if this is 6, then we will consider maximum possible is 6.5. And then for the minimum case, this one is 2. I want to make it as small as possible, so I will consider it is 1.5. 1.5. If you use calculator, 4.5 times 6.5, and then minus 1.5 square, 27. So our maximum limit should be 27, and not A and C. We are going to use similar logic for the minimum area. So for the minimum area, of course the original paper as small as possible, and the removed part should be as large as possible. So if we use the limit, the minimum for 4 to get 4, then it can be 3.5. If it is actual length is 3.5, then we still consider it is 4. 5.5 here. This one as large as possible, 2.5. So our minimum, possible minimum, is this, and then 13. So our lower limit is 13, and B is our answer. Don't forget this kind of question is you must draw clearly how you get the area and then consider the maximum case and what is the corresponding part situation. This one should be maximum and this one should be minimum for that. And if it is talking about the minimum final area, then the original part is minimum and the final the removed part should be maximum. So you can solve the question logically like this.